Good morning friends. Today we are going to discuss about the one more questions in electrostatics. Let us see this. This is from JTET Bhubaneswar, Zonal Institute of Education and Training, Bhubaneswar, and the topic is taken electrostatics, section A, 1 into 10, 10 marks. The first question is, a glass rod acquired charge by rubbing it with silk cloth. The charge in the glass rod is due to, your choice is friction, conduction, induction and radiation. The answer is given for choosing, that is a friction. So the explanation for this question is that, answer is that, so here the diagrammatic representation for glass and silk cloth, there it is rubbing. So rubbing, the meaning itself is called friction. So the two objects charged by friction gets oppositely charged. Charge acquired by the glass rod is positive and charge acquired by the cloth is negatives. Therefore, the main point is that it is due to the friction. Let us go to the next question. On charging, second question, on charging a neutral balloon, its size. What happened when a neutral balloon is getting charged? Whether it will be increasing or decreasing size? Let's see that. A increases, B decreases, C remains same, and D no relation between charge and size. So here neutral balloon, then getting charged. And what will be its size? Will be increasing. The answer will be increase. Let us go to the next third question. The flux through a cube of side, if a point charge of Q is at one of its corner is, that is A here given, one side A. So the flux through a cube of side A, if a point charge of Q is at one of its corner is, what happened to flux? The value is given here, A, Q by epsilon naught, B, Q by 2 epsilon naught into 6A, and C, 2Q by epsilon naught, and D, Q by 8 epsilon naught. This is here 6A square, it is not 6A square. Q, that is B is Q by 2 epsilon naught into 6A square. Let us see the answer. Answer is D, Q by 8 epsilon naught. How it has come? Let's see the explanation of this. So this is a cube which is having this 8 parts identical. So 8 identical cubes are required so that one 8 charge Q appears at the center of the bigger cube. So the electric flux passing through is given by the cube 1 by 8, psi is equal to 1 by 8, and Q by epsilon naught is equal to Q by 8 epsilon naught. So answer will be the D. Let's go to the fourth question. A parallel plate capacitor of capacity 50 microfarad is charged to a 10 voltage. Its energy is equal to, so a parallel plate capacitor of capacity 5 microfarad is charged to 10 volt. Its energy is equal to, how much the energy will be? Parallel plate energy is, the equation is that, you have to say that. And substitute the values are given here, 2.5 in 10 power minus 3 joule, 2.5 in 10 power minus 4, then C 5 in 10 power minus 2 J joule, and D is 1.25 in 10 power minus 8 joules. So which one will be the answer for this question? Let's see that. The answer will be A, 2.5 in 10 power minus 3 joule. Let's see the explanation for this question. So this is a parallel capacitor, and energy equal for energy, you know that the energy is equal to eta V, that is equal to half F naught E square AD, and this all together half F naught V square by D square into AD. A dd will be cancelled, half F naught A by D V square, that is equal to half C V square. This F naught A by D is nothing but capacitance of the capacitor, availability capacitor. So that when I substitute the value for the half into C V square, so half into substitute 50 microfarad into 10 square 100 divided by that, sorry, V square 100. So when you are dividing the equation, you will be getting by 2. So this is 25 will come and 100. Now will 2.5 into 10 power minus 3 joule. I will substitute it and find the answer. Okay, see you must know the formula for the particular topic. Let's go to the fifth question. In the direction of electric field, potential, electric potential, what will happen? Choice is given: A decreases, B increases, and C remain constant, and D is none of these. So answer is given decrease. But how it has come? Any explanation? So this is a uniform electric field. See, the diagram uniform electric field means equal spaced and same direction is called uniform electric field. The tested charge is moving from this point A to A to B. So the moving itself is called work done. Okay. So what happens in this, when a positive charge test charge moves from A to B, the electric potential energy of the charge field system decreases. So the work done is nothing but potential over the charge that is decreasing because it moves against the field, direction of the field. So the correct explanation is here. In the direction of electric field, the electric potential decreases. This is because electric potential is the work done against the direction of the electric field, naturally. Let's go to the next question. Sixth, a charge Q is enclosed by a Gaussian spherical surface of radius R. If the radius is doubled, then the electric dash will remain same. This is also seen to be a calculation type question, but can you guess for this 1 mark what the answer will be? Yes, the answer is flux will be remain same. Flux will not be changing. Let's see the explanation of this one. So that is the sphere. Okay, R is the radius of the sphere. Q is a charge, positive charge, and the small portion is surface area. And the electric field is this direction. Area also noted this direction. So the space around is called Gaussian surface. So in that, the flux will be the same. Flux is equal to integral of closed integral of electric field over the surface area, that is equal to charge by epsilon naught. Let's see the seventh question. A proton and an alpha particle enters into the region of uniform electric field. Think that a charge is moving into the electric field. Here not proton and alpha particles. So it will experience the force naturally. The ratio of the force on the proton to that alpha particle is, can you guess? The ratio of the force on the proton of the alpha particle is given 1:2. How it will be? Let's see the explanation. So alpha particle and the proton both are entering in the uniform electric field. I told you equal spaced direction source to that uniform electric field. See that explanation is, answer is, the force is called QE for electric field, okay, for the proton. Let us take the force on alpha particle divided by force on proton is equal to, that is Q is the force. So Q for the Q in case of alpha particles into E. Q in case of proton electric field. So electric field will cancel. So that in case of the alpha particle, two protons are there. So that one proton will be cancelled, QQ will be cancelled, the remaining will be get 2 by 1. Because charge of alpha is twice of proton. So the force of the proton divided by the force due to alpha particle is equal to 1 by 2. Well, this is the very good explanation for understanding you easily. Let us see that 8th question. A parallel plate capacitor of capacitance is connected and across the battery of the EMF E. If the separation between the plate is doubled, the force of attraction between the plates dash by the factor of dash times. Here also the force of attraction between the plate is asked. So what will be the answer for this? The separation of the plate between doubled. When D is doubled, let's see this diagram or any explanation. So that answer will be the force of the attraction between the plate is decreased and by a factor of 4 times. Let's see this explanation. When separation between plate is hard, capacitor doubled so that C2 is equal to 2C1. Let us say here capacitor and electric battery is connected. As battery is connected, so before that C2 is equal to C1 and voltage is constant. So charge stored in also doubles. When it is doubled, then it becomes Q2 is equal to 2 into Q1. Initial electric field is equal to E1 is equal to V by D and final it is after charging, that is V by D by 2 because the distance is doubled, half D by 2 where that is equal to 2V by D. So the 2 goes up, so 2V by D. Initial force of attraction F1 is equal to E1 Q1 EQ or QE. So that is nothing but V by D Q1. Already we have found the electric field. And the final force of attraction F2 is equal to E2 Q2, that is 2V by D because that is doubled. Then 2Q1. Then F2 is equal to 4 into V by D Q1. The force of attraction F2 is equal to 4 into F1 will be decreasing. Hence that decreases 4 times of that decreasing. I hope that you are understanding this one from this explanation. This is the diagrammatic representation of charging the capacitor and this is the distance between the two plates. Next, 9th question. Give an example where electric field is 0 but potential is not 0. A outside the cell, B inside the cell, C infinitive, D finite. Can you guess which one will be the suitable example for this one, which is inside the charged spherical shell, SHE. So the explanation for this will be, this is a positive charge enclosed by these surfaces. In cases 1, 2, 3, 4 cases. 4 spaces are drawn. These Gaussian surfaces are drawn. And this R is the radius from the center to this second region. And the first one A, second is written B, then third is C. This is unit vector. And the charge is minus 2Q. So that explanation in this case, therefore the integral of field from R to any points inside the cell will be 0 because no charge enclosed. So the potential at any point inside the cell is equal to the potential on the surface of the cell in case of equal potential surface. Thus, within the cell potential is non-zero. There is a good example of, this is the good example of some region devoid of field but having constant potential. The charge on the conducting shell creates zero electric field in the region R less than B. So here R less than B, what happened? That zero electric field will be there. So the cell has no effect on the field in the region 2 due to sphere, second region. Therefore, write an expression for the field in the second region as due to the sphere from part A. So we can find this from this one. The best example is that inside the charge is spherical and the electric field will be 0, but potential is not 0. I hope that we will go to the next. I hope that you might have understood. The 10th question, why what is not used as a dielectric between the plates of a parallel plate capacitor? So you must think about the dielectrics. What are the dielectric substances? Air, water, and glass or paper, whatever may be. These are all the dielectrics substances. In any case, what is to be an answer? Let us see, this is a capacitor separated by this d distance enclosed maybe air. Let's see this. Why water is not used? Because the relative dielectric strength is very low compared to the other dielectrics. That is why. More explanation on this one. Most of the time, an insulator is used between the two plates to provide separation. And the value of capacitance are not necessarily related. So what charge is stored in the capacitor if a voltage of 3 into 10 power of volt is applied to it? The polarity of water causes to have a relative